As we investigate matter, what we're really looking at is chemistry. And one of the major areas of chemistry is identifying physical and chemical properties of different materials. Physical properties are those that we see by using our five senses, like tasting, touching, smelling. What is the shape? What's it smell like? What's its color? Is it a solid, a liquid, or a gas? Lots of different things will help us to identify material by its physical properties. Chemical properties are another way to identify materials, and this is how a particular material reacts with other materials. How does it chemically combine? Now, at the primary level, we're going to focus mainly on the physical properties, and we're going to look in particular at making good, careful observations and using our five senses in doing so. Careful observations are very important, especially in the scientific method, because our conclusions, the outcome of all of our experiments, depend upon careful observations. Now it is important that we look at the five senses and see how we can go about developing these observational skills. When I think about teaching the five senses, I also think about how important they are to me, and how too often I take them for granted, and I don't really give them the appreciation they should get. And it's not sometimes until we lose one that we can really appreciate it. I think about which sense is the most important one, and for me it would have to be vision. Because with vision, you can distinguish many physical properties about a material, the shape, the size, the color, even the texture, by just looking at it, and you can tell how far away an object is from you. Now that, in and of itself, is really fantastic. It's like a built-in radar where we can sense objects coming toward us or moving away, or danger that may be approaching. So we want to explain what vision is, and it used to be explained as like a camera, but it's even better to explain vision as similar to a video camera. Both the video camera and the eye have a lens which focuses the light and projects an image on a screen. This screen turns the light energy into electrical energy. The electrical energy travels down through a bundle of nerves or wires and goes to the brain. In the brain, this electrical energy is stored, and in the video recorder, it's stored in the videotape player. Close your eyes and recall a memory. And if the picture is vivid, then it means that you picked up a lot of detail at the time. Just think of this. Every time we see something, that image is stored in our brain somewhere. Just a matter of retrieving the information. Now we want the students to have an appreciation for their vision and to really understand what it is and to respect it. You want to talk a little bit about safety. And one activity you might do to support this idea of how eyes tire is have them make one of these. Have them color a green, black, and orange flag like this, and make sure the borderline's black, and make sure there's a little dot right in the corner of the star field. The students work in pairs, and one of them stares right at that black dot for a full minute, and this flag is sitting on a piece of white paper. After the other student times the minute, he or she quickly pulls the flag away, and the first student is now looking at pure white paper. Make sure you have good lighting in your room for this. What the student sees is not what he thought he would see. It is an after image of these particular colors. And the colors that you see are the complementary colors. Your eye is tired of seeing green, and it can't see green. Although there's green in the white paper, your eye can't pick it up. So the predominant color is the opposite of green, which is red. So wherever there was green, there's red bands. Wherever there was black, there's white bands. And what the student sees is the red, white, and blue. Another way to show how important our vision really is to talk about the blind and how they survive in this world without being able to see. You can talk about seeing eye dogs, and you can talk about the Braille alphabet. You can look up the Braille alphabet in an encyclopedia and make a copy of all the Braille characters and the corresponding letter in the alphabet. And then you can give them a handout like this, with some rectangles in the top where they can put their name or a special word, and then some rectangles underneath that they can glue corn kernels on to represent the particular character in Braille. Now you'll note that these Braille characters are 2 points across and 3 points down. Now after they've done this one, you can give them another sheet just like it, and have them think of a word only and not write the word in the top, and glue in the corn kernels as if the word is represented in Braille only, and then pass this mystery word on to another student and have the other student decode it. And you might even have them practice feeling the corn kernels to see what it's really like to be blind. Making good approximations is an important skill. These two activities will reinforce that. Think about how many times you have to make approximations. Well, this first one, fill the glass to the very top with water. Then have the students make a guess how many pennies they think they can put in the water before the water overflows. You'll be surprised that it's quite a large number. Going along with this idea of making good approximations, have you ever wondered how many drops of water you can put on the side of a penny? You can have your students try this activity, but make an approximation first. Have them take a guess how many they think they can put on. They'll be surprised how many drops you can really put on the side of a penny. Then you might go a little further and see if it varies from the tail side to the head side. And then you can even change the composition of the water by stirring a little dish detergent in it, changing a variable now, and you'll find the results are different here too. Now let's take a look at our next most valuable sense, the sense of hearing. As we investigate this sense, we want our students to have an appreciation for it and also to safeguard it. Now, what are some things you can do? Well, you can take a tape recorder and bring some sounds in that you recorded in the community. Play the sounds back, even a small portion of the sounds, and see how many students can identify what it is. And you want them to start using sound words, words that describe different sounds like plop, smash, crackle. And you might even read sentences to them and have them pick up the sound word in the sentence. You can use rattle cans, where you put a material inside and they shake it and try and identify what it might be by the noise it makes. Another thing to do is to have them mimic sounds. What kind of sound does a chicken make? We also want to cover people that have physical handicaps, people that can't hear. How do they communicate? Using sign language. And you want to talk about how amplifiers work, people that have hearing aids, and how we can actually amplify sounds by making our ears appear bigger by cupping our hands behind our ear. We pick up more sound. Many animals have larger ears, and some animals have ears that actually rotate around so that they can pick up sounds from different directions. Another thing we do is use our ears to triangulate on objects. We can tell the distance that a sound is from us by hearing the sound hitting both of our ears. You can reinforce this idea with a simple activity, where one student holds a paper towel tube in one ear, and another student comes up behind the first student and taps spoons a certain place behind their head. The first student tries to identify exactly where that sound is coming from. Now, without the paper towel tube, both ears are used to identifying sounds behind our head. But with the paper towel tube, not only is it directional coming out from here, but a sound that occurs right in this region will have to travel this whole distance and back before it gets to the ear. So it will give some surprising results. The best way to do this activity is to have your students work in twos, turn them loose for 5 or 10 minutes, and then have them report back their findings. You ask them to find out how this tube affects their hearing as far as locating points behind their head. Now, sounds can be sequenced and described and classified according to certain characteristics of the sound, like pitch and loudness. And sequencing sounds is a very important skill, and it's something that needs to be developed at an early age. Like a tree falling, the hatchet hitting the tree, and then the tree starting to creak, and then it kind of falling through the air, and then it hitting the ground. Interrelated sounds, and you might work with these on your tape recorder and try and order the sounds that they occur in a sequence. Now let's take a look at the other senses. Which one is most important next? Is it taste? Is it touch? Or is it the sense of smell? Since taste and smell are so closely related, we'll look at them as a group. And it's important that you stress safety before you even start any activities in this area. Shouldn't taste anything you don't know what it is, and you should properly smell a chemical. Now, how to properly smell a chemical? You're not sure what it is. Many liquids look clear, like water, and you may think they're water. You may be almost sure they're water, but they may not be. You don't want to stick your nose right into it. It could be ammonia. So the proper way to smell a chemical is to hold it about half an arm's length away, wave your hand over the top so you're diluting any vapors that might be coming from it with the air, and you're trying to see what that material is. You can move it closer, and eventually, if you don't detect an odor from it, then finally you can get your nose close to it and smell it. Instruct your students in the proper way of smelling chemicals, and make sure whenever you're doing any smelling activities that they're smelling them the proper way. They'll carry this idea on through life. One good activity is using cheesecloth and Dixie cups. Put some type of aromatic substance in each cup and number it. And I like to use little bits of cotton, and great things to use are some of the extracts that you can get in the grocery store. This particular one is cinnamon. You can use vanilla and orange and lemon and so on. You can use even pieces of real lemons or limes or oranges. Then you have the students try and smell the particular material and see what it is, and write down orange or lemon or peanut butter or onion or alcohol, anything that they might think it is. You might even trick them and put a piece of solid material in there, like a penny or a piece of glass, and that'll bring the idea out that some materials don't have any odors. Now, odors are caused by gases. Whenever we're smelling something, we're detecting a gas. So our nose is a type of gas detector, and it goes right along with our taste buds. When you eat a peppermint, for example, our taste buds cannot detect the peppermint. They can detect sweet, sour, bitter, and salty, but they can't detect an aromatic like peppermint. So you can have a student close their eyes and hold their nose with their fingers, stick out their tongue, and you can give them a peppermint. And they may, by feel, know that it's some type of lifesaver or something like that, but they won't be able to taste the peppermint taste until they open their nose. Then all of a sudden the aromatic peppermint goes into their nose sensors, and they can tell what it is. Many substances smell good, but when you go to taste them, you find that it's a whole different story. And a perfect example is a lesson I learned a long time ago. Is when I tasted some vanilla extract, and you've probably done it yourself. And if you're going to have your students taste this, remember it's about 70 proof, so have them be careful. One thing you can do with an activity like this is work with quinine water and 7-Up, tonic water. They look the same, they smell pretty much the same, but when you go to taste them, there's a noticeable difference. Another thing in solid materials are herbs, and you can go to your local grocery store and raid the pantry there, come up with some very interesting looking herbs, and have them try and identify by taste or just describe the taste. Now, you have to be careful here. Some of them are pretty hot, and like the bottom row, there's 4 that look pretty much the same. Cayenne pepper, paprika, cloves, and chili powder. And you certainly don't want to taste the cayenne pepper like I did. On the top I've got mustard and ginger, and I'm told the ginger's hot too. The safety that you should observe in an activity like this is make sure that if your students are going to be tasting these herbs, that they're not too strong, and yet they have a definite taste so that they can discriminate one herb from another. Now, you might want to work with pure white chemicals, things that they can taste and try and identify or see how one is different from another. In this particular one, I've got powdered sugar, baking soda, cream of tartar, which is very bitter, and cornstarch. There's lots of different taste activities you can use. You can even use your food coloring, and you can make things like blue 7-Up. So it doesn't look like 7-Up, but it tastes like it. So students can realize that sometimes their taste buds are really the ones to rely on as compared to some of their other senses. Now, using our sense of taste, we're going to further develop the scientific method, this time in a mini experiment. Give each of your students a hard candy. Have them pop them in their mouth all at the same time. Tell them they can't chew them, they can only suck on them. And have them raise their hand the moment the candy disappears. Meanwhile, you're recording the results on the blackboard, putting an X at the certain time, and make a graph with the number of students on the vertical axis and the time that the candy dissolves on the horizontal axis. Once all the students have dissolved the candy, you can look at the results and see a natural progression, the dissolving rate of candies. Now let's take a look at the 5th sense, the sense of touch. Studying the senses gives you the opportunity to build a student's vocabulary. Just as we need words to describe tastes and smells, we also need words to describe the texture of an object, using our sense of touch. This tennis ball, for example, feels round or ball-shaped. It feels kind of cool. It feels fuzzy. It's soft if I press on it, and it feels like it's got grooves along it. These are all good descriptive words, and it's necessary to have good descriptive words in the scientific method for our observations. To further develop the student's sense of touch, use one of these, the touch box. Here you want to put an object in, have the student come up, doesn't know what it is, the rest of the class can see it, and the student just describes the object, the characteristics of the object, using his or her sense of touch only. This particular object feels hard, it feels smooth, it feels cylindrical, that's a tough word, it's closed on one end and open on the other, and it feels like it has a little spout that sticks out. Getting the characteristics is of primary importance. Secondarily, we want to name the object. And why not use a piece of scientific equipment like this beaker, or some tools to have the students name different types of tools. Here they're learning two things at once, to describe objects and also words of materials that they're not familiar with. Now what about these little receptors, these little touch bodies that are all over our body that allow us to feel things? They tell us when we're in trouble as far as being too hot or too cold, when there's extreme pressure pushing down on a part of our body, or pain when we shouldn't be near something. How do we measure where they are? How can we tell where they are? Well, we have a simple experiment here that you can do in your class. Two ways to do it. The first way is to get a piece of cardboard and stick a couple nails in the edge of the cardboard. Make sure the points are going outward. I have these two nails separated by about 1 centimeter. Have a student come up and test different parts of his body to see if he feels 1 nail or 2 nails. First, the back of the hand, 1 nail or 2 nails. Well, that's pretty sensitive. Try the arm, 1 nail or 2 nails. That's pretty sensitive also. Very sensitive part is the fingertip. They should feel 2 nails there. A part that's not very sensitive is under here in the elbow, and here I only feel 1 nail, which means that there's not a lot of touch receptors there. They're fairly far apart, and we really can't tell the difference between 1 nail or 2 nails here, and you can test this by actually pinching the skin under your elbow. It's not very sensitive at all to pain. And other places like earlobes too are very few touch receptors. Test different parts of the body so the students realize that these little touch receptors are very close packed together in some parts of our body where we need to have them, like our fingertips, and they're very far apart in other places like the skin in our elbow. Now if we want to actually measure, find a relative measurement of how close these are, we can go on to this activity. Here we're using 2 rulers. And on the end of each ruler I've taped a nail. And you now have an apparatus like the cardboard one, but you can slide it up and down to separate the distance between the nails. You want to start with them fairly far apart. I'm starting at 6 centimeters, this distance from here to here. And you want to test one particular body part. We'll test the arm first, and you want to record your data. How many points do you feel? Well, I feel 2 now. Then you close it down a centimeter at a time. Do you still feel 2? Yes. Down to 4 centimeters. Finally, you get to a point where you only feel 1 point from this little apparatus. Here I only feel 1 point hitting my arm. Even though I can see there's 2, I only feel 1, which means that I don't have a lot of touch receptors close together on my arm. You might have various students make these measurements to see if they agree. Where is the most sensitive part of your body? How about the fingertip? How close can you get? The closer you can get, the closer your little touch receptors are. How about places like the lips or the tongue? Lots of really interesting things you can do with a little piece of apparatus like this. Now there's 2 more topics that should be covered in this course on matter. The first is using our senses to determine the difference between the 3 states of matter: solid, liquid, and gas, and trying to see why one is different from the other. The second topic is making measurements, how we make measurements, what we use for units in measurements, and some common measuring devices. One way to illustrate all 3 states of matter at once and get the students introduced to the idea that there's the chemical properties too, is to fill your fish tank up with water and introduce them to Alka-Seltzer. Now, Alka-Seltzer, when combined with water, gives off a gas. That gas is carbon dioxide. And we're going to now look at all three states of matter at once. Take a glass and fill it with water in the tank and turn it upside down and drop the Alka-Seltzer tablet in. The students will see right away that the tablet gives off the gas. So we have solid, liquid, and gas all at once. This demonstration also shows one chemical property of Alka-Seltzer, that it changes its chemical makeup and produces a gas when combined with water. As the students make further investigations into solids, liquids, and gases, they'll also be developing their scientific skills, making good observations, making predictions, making inferences. And you can get a glass of cold water and a glass of hot water and have them predict that if a bouillon cube was dropped into each, which one would dissolve first. Here you want to talk about the water particles moving around more rapidly in the hot water and hitting that bouillon cube with more force and actually breaking it up sooner. Now you also want to talk more about the particles in the solids and the gases too. In the solid, the particles are bound together. They're not moving freely, and all they can do is vibrate in place. Because the particles are bound together, a solid takes up a definite shape. In a liquid, the particles are sliding past each other, kind of like bees in a beehive moving all over each other. And that's why when you pour a liquid, the particles slide past each other and the liquid pours. In a gas, I like to think of the bees as all flying out in different directions, and that's what a gas is. The particles are randomly moving in different directions. Your students will see from this activity that, sure enough, the bouillon cube in the hot water will dissolve first. Now there's some more activities you can do. One, give them a plastic bag and an ice cube, and you can carry the ice cubes into class with a thermos bottle to preserve them throughout most of the day. Have them put the ice cube in the plastic bag and seal it up. When you start the clock, everybody begins to try and melt their ice cube first. Whose ice cube will melt first? You can keep track of the time on the board and find out which student won and how he managed to melt his ice cube. Now it's an experiment in heat. It's also an experiment in inventive process where they're trying to invent ways to make it melt first. And thirdly, they're taking a look at solids and liquids. And you might want to talk about physical properties here. This is still water, whether it's solid water, liquid water, or even if we heat it up more and it turns to steam. Now another activity we can do is get some milk cartons and put different materials in them. You can put liquids and solids and gases in different ones and label them. Have the students go around, shake them and feel them and see if they can identify what's in them. This particular one feels like it's got just air in it, but really has cotton balls in it, so that's a good one to put in. Another thing you might do is put something like honey, something very thick in one, so it doesn't really feel like it's a liquid. And you can ask the students to do something to these containers to get more information about what they think is in them. Like hold a magnet next to it to see if it sticks to the side, if there's something metallic in there. Or poke a hole in the side to see if the liquid pours out. Or even drop it in a tank of water to see if it floats. Now, the other idea we're getting across here is a basic idea of density, and that's very important, where you have one particular material that takes up this amount of space and another material that takes up the same amount of space but weighs much less than this one. So this material is a lot more compact than this one, and sounds like we got jelly beans in this one. When you introduce your students to making measurements at the primary grades, it's important first to talk about the word unit. And what are units? Well, a unit is a word that follows a number, and that word describes how you measured the quantity. In other words, it might be 15 feet, or in the case of measuring horses' heights, it might be 17 hands, where a hand is equal to 4 inches. Now we have lots of sometimes strange units, especially in the English system, and we also have our metric units. And I think it's important that we learn both at once so that the students can kind of get a relationship of about how many centimeters equals about how many inches, and how many degrees C is equal to about the same temperature in degrees Fahrenheit. Some of the things we want to measure are weight, length, and volume. Now when we talk about units, you might want to start out with making your own units. One of the things you can do, and there's lots of activities in this area, have your students outline their foot or their shoe and then cut it out and call it a one-shoe unit. And then you can have them do lots of things with their shoe. You can have them measure their height. How many shoes tall are they? And you might compare the shoes to see if the shoes are the same. And then this brings up the idea of why we need to have standardized units. Why one person's shoe in one side of the room is not equal to another person's shoe. And where the problems occurred many, many years ago, and finally people had to come up with standardized units. So now we go to part 2 of the one shoe measurement. And you ask your students, what can we do so that every student in the class gets the same numerical value for a particular measurement? Well, the answer, of course, is to have a shoe that's the same size. So you come up with a handout like this. We'll call it the big shoe, or the foot. And make sure that your foot is subdivided into 12 equal parts, which we'll call inches. And have your students go around the class and make measurements of certain things in quantities of feet and parts of a foot, which we'll call inches. I'm sure you can see where we can go from here to tape measures and centimeters and rulers. Learning to measure involves practice, making lots of measurements, and making approximations or guesses before each measurement is made. Now remember that if you don't include the proper units after the number, then the measurement is invalid. Weight is the next thing we're going to investigate, and it's an ideal quantity for developing the skill of approximation. People ask me, what is the most valuable piece of scientific equipment that a school can have? And I would have to say the balance. Every elementary school should have one good balance. The more balances you have, the better. Then you can get all of your students working at the same time. Now there's a number of different kinds. I personally prefer the single platform balance. You may have at your school already something like this, a double platform balance, and there's nothing wrong with these. The only difficulty comes in deciding which platform to put the object on that you're going to weigh. Now, working a balance is really very easy, but there is a standard operating procedure that you have to follow. The first thing is to make sure that it sits at 0 when all the weights are set at 0. That's called tearing the balance, T-A-R-E. And this has, all these weights have to be at 0, and the little balance must sit right at the center line. The next thing is, how do we go about making a measurement? Well, let's see how much this piece of quartz weighs. The first thing you'll notice is that this is called a triple beam balance. It's called a triple beam balance because it has 3 separate beams with weights on them which move. The center beam is the heaviest weight, and it goes from 0 to 500 grams in 100 gram increments. The next heaviest beam is the upper beam, and that's the tens, and it goes from 0 to 100 grams in increments of 10. And the final beam down here is the ones units. It gives you single individual grams and tenths of a gram. So it's a very sensitive balance. Now, how much does this piece of quartz weigh? Well, to weigh it properly, you have to start with all the weights set at 0. So we'll move all the weights back to 0. Then you want to move one weight first. The first one you move is the heaviest one, and that's the hundredths. And you move it one notch at a time until the balance falls. It falls, so you back it up a notch. Then you go to the next heaviest one. That'll be the tens. You do the same as you did with the hundreds, moving it one notch at a time until the balance falls. 90, 90, so you back it up a notch. We've got it set here to 80. Then finally, you'll always get it to come into balance with this little slider that has the ones and the tenths of a gram. So somewhere along here it'll come into balance. That's where the 0 mark and the needle line up perfectly, right about there. The final task for your students is adding up the weights so you can get the total weight. We have 182 point, and you go 0.5678. So we have 182.8, and the units are grams. 182.8 grams for this piece of quartz. Balances have many uses. Once your students are familiar with making separate weighings, then you can have them start approximating, making a guess at how much, say, a paper clip weighs, or a pencil, or a battery, and then going and measuring and see how close their guess was. If you need to extend the capacity of this balance, there's extra weights that you can get that hang on the end. Now, these weights will increase this balance capacity from 600 grams to 2,600 grams, which is over 5 pounds. In your classroom, you can use a balance to make some unique and interesting measurements. For example, you have a bunch of rulers, and before you hand them out to your students to use, you weigh them to see how many you have or how much they weigh. And then when they all come back, you weigh them again to see if they weigh the same. If they don't, you know that a student still has a ruler out there. They'll see that as an interesting way to count. Now let's go on and let's take a look at the third and final measurement that we're going to deal with at the primary level, and that is measuring volume. In this case, volume is not the right-hand knob on your radio. It's a measurement of space, the amount of space that an object takes up. And for example, how much space does this piece of wood take up? Well, the best way to treat this problem is to use the old bathtub principle, and I'm sure we've all done it when we were young. When you climb in a bathtub that's filled to the top, like you wanted to make a swimming pool, one of the things you notice is that all the water runs out on the floor, or at least some of it does. It's the amount of water that your body took up. Now the next question is, isn't that water that ran out equal to the same amount of space that this little block took up? Well, we're going to use that principle to measure volume of objects, and we're not going to be this messy. We're going to use something called an overflow can. Now you can buy them commercially. It's just a can with a little tube grommeted in, or you can make your own out of a milk carton, where you cut a V shape in the side of the carton and make a little spout that goes down. Now the way to do this is to get your can and set it up in a convenient place. Then you need an empty container underneath it, so we'll use this beaker. Then you want to fill the can to overflow so that some liquid starts coming out of the spout. And then you wait until it completely stops dripping. You might even point this tube down a little bit here. Once it stops dripping, you make sure that this excess water gets poured out, so we now have an empty beaker, and anything we put in this overflow can will make water come out. The water displacement method is what this is. Let's say we wanted to find out the volume of this piece of quartz. Well, very simply, we just carefully drop it in. We get to this certain point, and we can let go of it. Now, we've come to the conclusion that this amount of water takes up the same amount of space as that quartz rock. Now the only problem is finding out how much water we have in this beaker. Well, now you need another measuring device, and this one is called a graduated cylinder, and I recommend at the primary level in particular that you get the plastic ones. It's a matter now of just pouring the liquid into the graduated cylinder, and remember that water has a tendency to bow. It kind of loops down, and you want to read the bottom of the bow. It's called the meniscus, and you read off the number of milliliters, which is also the same number as cubic centimeters of liquid that equals the same amount of volume as that particular object. Although this activity is a little messy, it's great fun as your students find the volume of various objects. Now we go on from chemistry and take a look at mechanics.